Okay, hi everybody. I'm going to continue talking about RNNs and time series. We'll touch on, we're focusing on text data today, um, and we're going to have some more lectures on transformers later. So, but I think there's so much really to this topic in the book, associated with the book, and try some of the other tutorials that I'll mention as we go through. So let's get started. So text data is clearly really an important source of data, and I'm sure you guys can think of a lot of projects that would focus on text data. So let's think about some of the tasks, and maybe it's an exercise that you want to pause the video here and think about different tasks and applications you can imagine doing with what we call a corpus of text. A corpus of text is a collection of documents, and a document could be something like a tweet, it could be a blog post, it could be a page in a book, it could be an essay, any kind of collection of text could be a document. So we have, characters, and then characters are put together to make words or sentences. Sometimes the words are not separated in Asian languages, for example. And then sort of the larger segment is documents. So let's give some example text tasks. So one would be sentiment analysis. You'll see, there are whole libraries for doing this. There's lots of projects for doing this. At a sort of a simple level, it would be, trying to determine whether some document or some tweet has a positive sentiment or a negative sentiment. Sometimes it's called, an extension of this is called the emotion detection or emotion extraction, and to try to figure out what emotions are being expressed, anger, joy, and we can think of lots of applications, user reviews, rather than have people rate it with a star, you could kind of read their text to get their emotion out. Customer support, so companies are looking at the reviews of their products and they're trying to identify, whether the product has a problem. And content moderation, obviously, if you're running a social network site, you want to identify the trolls. Okay, so that's one class. Topic modeling is both kind of a medium level technique, and which can be used for other things, but in and of itself is pretty interesting. So the question is like, what topics are in this document? Is it about kind of extract a tone? This is directly trying to figure out what topics are being discussed. And this could be for search or content moderation again. If it's supposed to be about programming and people are starting to talk about advertising, so it's spam or it's political or something like that, you may want to flag that. Document clustering, so if you have a bunch of documents, these are all on an election, and these are all about this, you could kind of separate them by topics. Content recommendation, if you know what the topics are and people are interested in a certain topic, you could recommend it to them. Trend analysis, so there are there's like Wall Street Bets, and there's all these news groups that follow stock or follow crypto coins or something like that, and if people are getting nervous about it or people are getting excited about it, you could, assign these metrics and track it over time and see how it's changing. So trend analysis and summarization, right? Give me the gist of, what is this document about? Related, of course, is search and retrieval. So if I'm interested in certain kinds of documents, I like to be able to find, I might be able to type a question or some keywords or something like that, and I wanted to find the documents which are about that. Even if my keywords aren't exactly correct, I want it to be semantically, identify which documents are related to my query, or which parts of documents. You can think about, there's so many applications of search, but, patent searches, for example, you have an idea for some kind of a patent, and you have to search to see if this is really original. Medical diagnosis or, prognosis, how do you treat something? So, the literature on medical stuff is very vast, and you'd like to be able to quickly identify papers that or new techniques, new studies on treatments, and just in more general research, right? Is you're coming up with some idea, you want to see if it's a good idea, and you want to see what other papers or what other techniques, algorithms are in the same field. Okay, so question answering. There's many benchmarks where this is evaluated, but there's some specific knowledge questions that you might have. Things that you might type into Google. Again, it's kind of search, but you want the answer. You don't want the whole. You don't want a document that's related to it. You want to know, where what are the places that George Washington lived, or where some battles happen, and you just want the answer. Customer support is an application of this. People are having some trouble with something, and they want to know what to do, what steps to take. Business intelligence research. Another text, thing. You're probably familiar with Grammarly, but you write documents all the time, and you'd like them. You'd like to have an editor who could help you out and check the grammar and spelling. Do the proofreading for you, basically. Fake news detection, right? When people are posting news that it didn't happen, or is sort of malicious, it's meant to misinform, we'd like to be able to know that post is fake. Plagiarism detection, kind of pretty obvious what the goal is and what the application is. Machine translation, that means translating one language to another. So you write something in English and you like it sort of auto translated into Spanish and Chinese and other languages, Arabic, so people can also read it. Sort of more generally, text generation. That's something obviously with ChatGPT and Llama 2 and these other models that we're considering, are pretty exciting. Particularly chatbots that we've been building, or automated code generation. Type a prompt in and have it build an SQL query for a structured database, or have it build some code to do visualization. Machine translation from one language to another is an example of text generation as well. So these are not like separate things that kind of overlap. Text summarization. So again, you can think of this as being, partly kind of an application of text generation, but you've got a long documents, you want overviews of them, you want book summaries, or you have a collection of documents, and you want to see what are all these documents about? What are the common themes? How do they differ? Author identification. So somebody has wrote a document, and you want to identify who wrote this document. You can imagine that being important for like historical analysis, historic documents, and who wrote them, or forensics, right? Somebody, the Unabomber wrote this manifesto and sent it to the newspapers, but part of the way that they found him is somebody read the manifesto and kind of recognized that it was probably this person. So obviously, security applications. So there's a lot of applications for this kind of thing. All right, so in this course, we're mostly using PyTorch. Of course, you can use TensorFlow if you want to, but for parts of working with texts, it can be advantageous to use some other libraries for pre-processing the text, also for getting corpuses of text. You should consider these other libraries that may serve a role in doing things, and not try to do everything in PyTorch or Torch Text or FastAI. I mean, those are good and they cover a lot of ground, but there are more full-featured libraries. So let me say a word or two about them. So the first thing I want to mention is regular expressions. So regular expressions are like a fundamental tool that everybody who works with programming, and especially languages like Python, ends up using quite a bit. It's really handy. So I'm not going to go into. I've linked below to some tutorials, but essentially you can say, this is, the form of something. Like it's supposed to be a string and then an @ sign. I'm looking at this first one, and then after the @ sign, it's a name, and then a dot, and then another name, and then a dot, and then it's maybe a top level. And there's rules obviously for domain names, for email addresses, in terms of what can be in which characters can be used in an email address. So all the phone numbers. So you can identify patterns of text within a text, and then be able to extract them, or find them and then be able to extract them, locate them, and then pull out the individual bits and use them. So this is incredibly useful, and it comes up all the time. You might have log files that you're actually going to do text analysis on from, and then you want to strip out some of the formatting and reformat it in a way that your language model would be easier to analyze it, or so forth. So when people start to play with regular expressions and see how powerful they are, they get very excited about it. And then there's a joke quote of a very famous programmer who said, some people when confronted with a problem think, I know, I'll use a regular expression. Now they have two problems. So, the formulating the regular expression is its own little puzzle. And, it can be a little bit of a rabbit hole. So, be careful with those. Okay, so this is for like basic things, really. And I did mention things like text scraping with Beautiful Soup, or other libraries that are for specific kinds of text, for extracting text from a PDF. There are Python libraries for doing that. So, for your projects, I'm expecting you guys really to be be using a data set that exists and not creating your own data set, but it may be that you're going to have a project that involves, getting a collection of PDFs and doing something with it, doing some text analysis on it. And if that's your project, that's fine. There are libraries for doing that, and regular expressions might be helpful. Okay, so once we have sort of documents in the text form, this could be as CSVs or pandas data frames or whatever. There's a bunch of steps that we want to go through to process these things, and I'll talk about those steps, a number of those steps later. Now, in the olden days, not so long ago, before deep learning and some of these newer models, there was a lot of pre-processing people would do with text. So they would remove what's called stop words, which are little words like if and in and is, very common words, so that they could take a document, particularly for topic modeling, right, and extract out the words that were representative of that document. The words that are maybe not super common in the language in general, but are distinctive for recognizing those documents. So the stop words are the words that are just common in the language and that every document's going to have it. The, for example. So you might want to remove those, and then tokenization we'll talk quite a bit about. And then stemming, I'm not going to go into all of the details of these different techniques, but stemming is like when you have different parts of speech, not different parts of speech, but like tenses like run, running, ran, and you want to just replace it with just the word run as a placeholder for that concept that somebody is running in some place. Rather than get confused by having three different versions of this, especially if you're doing something like a counting how many times run appears in a text to indicate whether that's what kind of a document it is. So, and then tagging different parts of speech, verbs, nouns, parsing, so these are all pre-processing steps that have traditionally been used in natural language processing, but nowadays, we often just use tokenization and not some of these other techniques because it's not as necessary to do the pre-processing with a deep learning model sometimes. So this library, which I'm talking about right now, NLTK, which is the Natural Language Toolkit, it has all of the sort of classic stuff. It has a very large collection of data sets. It has metrics, which are very useful for sort of relating, how similar two documents are. It can extract all kinds of different kinds of features. It has some models, and it has just a ton of stuff. The thing about it is can be a little tricky to install sometimes. It has a somewhat steep learning curve, so there's great tutorials on it and so forth. But it's a big library with a lot. It's a bit slow nowadays. It's quite slow because it's CPU, and people haven't they're not changing the library that much, and kind of updating it. If there's a particular kind of feature that you read about and you think, oh, I should use this, it's likely to be an NLTK, especially if it's an older feature. If you wanted to get parts of speech, for example, it's in there and all this other stuff. But at the same time, it's sometimes not used as much because all of those features aren't necessarily needed, and sometimes. So anyway, it's a really important to know about, and if you're looking for some even just data sets that you want to be able to test out your ideas on, you might look at NLTK just to get the data sets in. Okay, so a little bit more of a modern model for pre-processing and doing a lot of the stuff that you're going to do before you do deep learning is SPACY. So it can identify from a text, what language it's using. It can extract a vocabulary. So these are the words. Do tokenization. It has built into it some embedding models. It has a concept of pipelines, so you can set up, first do this, first do that, first do the other thing. It's very fast. It has some GPU support. It has features, and it's actually Fast AI uses it under the hood for stuff. So you can use the Fast AI version for some of the things, and then you can actually dig down and use a SPACY for some more detailed pre-processing if that helps get you some better performance. So definitely a really important library to be aware of. GenSim is also a really good and modern library. It doesn't really have GPU support, but it's very fast. And it's more oriented towards topic modeling. So, extracting from documents what topics are available. It has a whole bunch of, topic extractors built in. And it has a whole bunch of embeddings, which also, SPACY has embedding models. And we'll talk about what embeddings are. But, if you should also look at GenSim and consider the embedding models it has, because it may have some better models or different models that give you better performance or are faster in some cases than SPACY or what you'd find in PyTorch. There's a few things in sklearn. So of course sklearn has all the classical machine learning, not the deep learning models, but remember I said that you guys should be always comparing with the baseline. And there are some very simple features that you can extract from text, and of course sklearn has logistic regression and random forests and a whole bunch of other classifiers or regression models or whatever that you could use to understand your data. So you might be using sklearn either with some of your results, with some of the pre-processing, and in particular, I'll mention TF-IDF, and that's that can take a document and turn it into a matrix, a sparse matrix of features, which could be used for classification. And it has some data sets like the Fetch 20 news groups. It doesn't have a lot of good text data sets, but it does have some. All right, so our primary tools in this course are PyTorch and FastAI. PyTorch has a bunch of, I should say that SPACY also has an ecosystem of libraries for doing all kinds of interesting things with text, and it's worth looking at that ecosystem. So PyTorch has also an ecosystem, but it has a bunch of libraries that are like built right in for doing text, image, audio processing. So PyTorch itself has like RNN embedding, which is useful for text. And this tutorial here, if you click on it, when I put the slides up, you can get to that NLP from scratch. So that doesn't use torch text. It's kind of like just using the basic PyTorch to do some basic classification model, just to show you how things work. And then torch text has data sets, it has metrics, it has pre-processing, it has embedding models. So it's possible that, besides sort of training a baseline model to compare your model with it, sort of get a comparison, you might just be able to use torch text and have all the pre-processing you need. So it's a pretty full-featured thing, and it has layers that you can put into RNNs, which we'll talk about, and has transformer layers, attention, all of these things. So there's all the ingredients there to make make your own sophisticated models. Okay, like I said, I'm not going to be able to cover an enormous amount today because there's just too much. But so this is I guess it's chapter 10, 11, and 12. This is based mostly on chapter 10. So this is the lesson on natural language processing that covers sort of the basics. And you really should watch this as well as what I'm going through now. And then, for this lecture, chapter 10, chapter 11, and chapter 12, give you a good introduction to using fast AI, which uses SPACY under the hood and pre-processing, tokenizers, transforms, NLP datasets. It has a lot of stuff in Fast AI, but of course Fast AI is actually using SPACY and other libraries to do a lot of these things. It just makes it a little easier. Okay, so that is on the tools. So let me stop the video here. It's been half an hour, and we'll start another video. So.